Hello, in this lecture we will find the radius of the red semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. We also know that side AB of triangle ABC equals to 3 units. And the line segment DC equals to 1 unit. And also side AB of triangle ABC is tangent to the semicircle at point B, and side AC, the hypotenuse of triangle ABC, is tangent to the red circle at point E. And we want to find out the radius of this red semicircle. Okay, so first of all, I will present to you a new rule number 1, or two tangents theorem. So rule number 1, or two tangents theorem, states that the lengths of two tangents, from a common external point to a circle are equal. So I'll repeat on two tangents theorem again. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of the two tangent theorem? The meaning of two tangent theorem is that if you have a circle, for example, this blue circle, and we have also point P. This point is point P. Point P is an external point. Point P is an external point of this blue circle because point P is not located inside the blue circle nor on this blue circle, but it is located outside the blue circle. Therefore it is defined as an external point of the circle. And so if from the external point, point P, we will draw two tangents to this circle. So this is the first tangent, and we'll define the touching point between the first tangent and the blue circle as point A, and we will draw a second tangent to this circle, and we will define the touching point between the second tangent and the blue circle is point B. Actually, the size or the length of the first tangent is PA, and the length of the second tangent, it is actually PB. And according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So we draw two tangents to this blue circle from the common external point, point P. Therefore, according to two tangents theorem, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. So whenever you draw two tangents to a circle from a common external point, like in this drawing, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. And we actually can implement all two tangents theorem in our drawing. In our drawing, we have the external point, point A, and from the external point, point A, we have two tangents to the red semicircle. The first tangent is tangent AB, and the length of tangent AB is 3 units, so the first tangent is tangent AB, and the second tangent is tangent AE. So whenever you have two tangents from an external point of a circle, then the length of those two tangents are equal to each other. That is to say, AB equals to AE. According to two tangents theorem, AB equals to AE. The first tangent, the length of the first tangent AB equals to the length of the second tangent AE. But we know that AB equals to 3 units. It is given us in the question. AB equals to 3. So from this equality, we will conclude that AE also equals to 3 units. Okay? AE also equals to 3 units. Okay? And in the next step, I will present to you a new rule rule number 2. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I'll repeat again on rule number 2. Actually, rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if you have a circle, this blue circle, the center of this blue circle is at this point. We will define the center of the circle as point O. Then we have tangent to this blue circle actually tangent AB. This tangent is tangent to this blue circle at this point. We define the touching point between tangent AB and this blue circle as point M. Actually, point M is the point of tangency of tangent AB with this blue circle. So point M is the point of tangency of tangent AB with this blue circle. Okay, and we also have a radius that starts from the center of the circle and ends at point M. That is the point of tangency. OM is the radius of this blue circle. So, according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. Actually, this radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, this radius is drawn to the point of tangency, that is to say, it is drawn to point M, then the tangent AB will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So that is the meaning of rule number 2. We can actually implement rule number 2 in our drawing, because in our drawing we have tangent AC is tangent to this red semicircle at point E. Point E is the point of tangency of tangent AC with this red semicircle, point of tangency. So here we will define the center of this semicircle as point O. Actually, BO is the radius of this red semicircle because of the fact that line segment BO starts from the center of the circle and ends at point B. That is a point on the semicircle itself. Therefore, line segment BO is the radius of this semicircle. So we will define the radius of the semicircle as R. Therefore, BO will be equal to R. Likewise, DO, line segment DO. Line segment DO is the radius of this semicircle because it starts from the center of the semicircle and ends at point D, that is a point on the semicircle itself. Therefore, DO is the radius of this semicircle, so we'll call it R. It equals to R. Then we will join together points O and E by a straight line. Actually, line segment OE is the radius of this red semicircle because of the fact that line segment OE starts from the center of the semicircle, that is to say from point O, and ends at point E, that is a point on the semicircle itself. Therefore, OE is the radius of this semicircle. Therefore, it equals to R. So here we have this radius, the radius OE, is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency, of tangent AC with this red semicircle. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees, according to rule number 2. Whenever you have a radius that is drawn to the point of tangency, like in this drawing, then the tangent AC will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle equals also to 90 degrees. So because of the fact that angle OEC equals to 90 degrees, therefore, triangle OEC is a right triangle because it has one angle that equals to 90 degrees. So the green triangle OEC, is a right triangle. So we will focus on the green right triangle, triangle OEC. I will repeat again, triangle OEC, the green triangle, is a right triangle. As you already know, in any right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. I will repeat again. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in this green triangle, the hypotenuse is side OC because it is located in front of the right angle. So, according to the Pythagoras theorem, the square of the hypotenuse, so the square of the hypotenuse is OC squared, equals to the sum of the squares of the perpendiculars, equals to OE squared plus EC squared. We will define side EC, the side EC as x, that is to say side EC equals to x units in its size. So I will repeat again. According to the Pythagoras theorem, in the right triangle OEC, the square of the hypotenuse, that is to say OC square, equals to the sum of the squares of the perpendiculars, equals to OE square plus EC square. Okay, so, but what is the value of OC? So you can see from the drawing, the value of OC, or the length of OC, is r plus 1. Okay, OC equals to r plus 1, so if OC equals to r plus 1, then OC square will be equal to r plus 1 square. Okay, so OC square equals to r plus 1 square, and it equals to OE square. What is the value of OE? OE is the radius of the semicircle, so it equals to r. So if OE equals to r, then OE square will be equal to r square plus EC square. EC, side EC of the green triangle, equals to x units. So if EC equals to x, then EC square will be equal to x square. So in total we found out that OE square equals to r square and EC square equals to x square. So r plus 1 square equals to r square plus x square. Here it is actually r plus 1 square. I forgot the square. So here we will open the brackets in this side of equation number 1. R plus 1 square is actually r square plus 1 plus 2r, according to the algebraic identity that a plus b square equals to a square plus b square plus 2 times ab. Okay, and it equals to r square plus x square. Here we have r square in both sides of equation number 1, so we will subtract r square from equation number 1, so r square will get cancelled. And what is left after we cancel r square? What is left? It is actually 1 plus 2r equals to x squared. So we found out that according to equation number 1, 1 plus 2r equals to x squared. Okay, so in the next step we will focus on the right triangle, triangle ABC, and on the green triangle, triangle OEC, and we will actually prove that those two triangles similar to each other. Okay, so we will focus on triangle ABC, that is the big right triangle. In the green triangle, triangle OEC, that is also a right triangle. So first of all, we know that those two angles are equal to each other. They are both right angles. So we can write down that angle ABC, this angle in triangle ABC, equals to angle OEC, this angle in the green triangle, triangle OEC. And both angles are right angles, they are both equal to 90 degrees. So we actually found out that angle ABC equals to angle OEC, and they are both equal to 90 degrees, they are right angles. And we also know that this angle is a common angle, it belongs to both triangles. It belongs to triangle ABC, and angle C also belongs to the green triangle. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. I will repeat again. Angle C equals to angle C. It's a common angle that belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. So actually this angle, angle BAC in triangle ABC, equals to angle EOC in triangle EOC, this angle, and they are equal to each other. Those two angles are equal to each other according to third angle theorem. I will repeat again. Angle BAC equals to angle EOC. They are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem, or also you can call it rule number 3 or third angle theorem. 3, so we will write down the third angle theorem or rule number 3. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. I repeat on rule number 3 again. According to rule number 3 or two angles theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of third angle theorem? The meaning of third angle theorem is that if you have two triangles this triangle is triangle ABC, and we have also another triangle, triangle DEF, and those two triangles have two pairs of angles that congruent. The first pair of angles that congruent are those angles. This angle is alpha, and this angle also equals to alpha, so those are the first pair of angles that congruent to each other. They are both equal to alpha, and we also have second pair of angles that also congruent to each other. This angle is beta, and this angle also equal to beta, so those pair of angles also congruent to each other. They are both equal to beta, and suppose that this angle equals to gamma and this angle equals to theta. So those are the third pair of angles. So according to third angle theorem, if this is the situation that we have two pairs of angles that can go into each other, this is the first pair of angles that can go into each other, this is the second pair of angles that can go into each other, then the third pair of angles must also can go into each other. That is to say, according to third angle theorem, angle gamma equals to angle theta. Okay, so this is the claim of rule number 3 of third angle theorem, that if we have already two pairs of angles that can go into each other, then the third pair of angles must also can go into each other. So we will prove that angle gamma indeed equals to angle theta according to the rule that the sum of the angles in any triangle equals to 180 degrees. If we focus on triangle ABC, according to that rule, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Okay, so according to the rule that the sum of the angles in any triangle equals to 180 degrees, in triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles also equal to 180 degrees. So in triangle DEF, the sum of its angles is actually alpha plus beta plus theta, and it equals to 180 degrees according to that rule. I will repeat again. The sum of the angles in triangle DEF also equals to 180 degrees. That is to say, alpha plus beta plus theta also equals to 180 degrees. So here we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that according to equation number 3, angle gamma minus angle theta equals to 0. Here we will add to equation number 3 theta, and we will get that angle gamma equals to angle theta. And that is what exactly we wanted to prove. We actually proved that if we have two triangles with two pairs of angles that are equal to each other, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta. Okay, we proved that angle gamma equals to angle theta. That is to say, the third pair of angles also equal to each other. Angle gamma equals to angle theta. So we proved that the third angle theorem is true. So we will repeat, we will return to our original drawing. We actually proved that all three angles of triangle ABC congruent to all three angles of the green triangle, triangle OEC. Therefore, we proved that triangle ABC is similar to triangle OEC. Okay, so I will write it down. We proved that triangle ABC is similar to triangle OEC according to angle similarity rule. I will repeat again. We proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So, what is angle similarity rule? Actually, angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of the other triangle, then you actually proved that those two triangles similar to each other according to angle similarity rule. Okay, and from the fact that triangle ABC is similar to the green triangle, triangle OEC, we will conclude that AB over OC in triangle ABC, AB over OC in triangle AB over AC in triangle ABC equals to OE over OC in triangle OEC. I will repeat again. Because of the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay? But what is the value of AE? The value of AE, according to what is given us in the question, OE equals to 3 units. So AB, the value of AB, according to what is given us in the question, AB equals to 3 units. So AB equals to 3. And what is the value of AC? The value of the hypotenuse AC, as you can see from the drawing, AC equals to 3 plus x. AC equals to 3 plus x. So we actually found out that AB is 3, AC is 3 plus x, and what is the value of OE? The value of OE, as you can see from the drawing, is R. It is the radius of the red semicircle. And what is the value of side OC of the green triangle? The value of OC, as you can see from the drawing, equals to R plus 1. So here OE equals to R and OC equals to R plus 1. Here we will cross multiply equation number 2, and we will get that times R plus 1 equals to R times 3 plus x. Okay, we will open the brackets in both sides of equation number 2 here, and we will get that 3r plus 3 equals to 3r plus r times x. So that's what we got after we open the brackets of equation number 2. So here we have 3r on both sides of equation number 2, so we will subtract 3r from equation number 2. So 3r will get cancelled, and what is left after we cancel 3r? What is left is actually 3 equals to r times x. So here we will divide equation number 2, this equation, by x. It is allowable to divide equation number 2 by x because, as you can see from the drawing, x is one side of the green triangle. It must be a positive number, it can never be 0, therefore it is allowable to divide equation number 2 by x. Okay, so we will get that after we divide equation number 2 by x, we will get that r equals to 3 over x. So we found out that the radius of the semicircle equals to 3 over x, according to equation number 2, but we have already found out that according to equation number 1, 1 plus 2r equals to x squared. So we can substitute r in this equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. So we will do it now. We will substitute r by 3 over x in equation number 1. We will get that 1 plus 2 times r is 3 over x according to equation number 2, equals to x squared. So here 2 times 3 is 6, so we will write it down. So 1 plus 6 over x equals to x squared. So we multiplied 2 times 3 is 6, and we got this equation number 2, that 1 plus 6 over x equals to x squared. Here we will multiply this equation number 1 by x, and we will get that x times 1 is x, 6 over x times x is 6, x squared times x is x cubed. Okay, so here we will subtract from this equation number 1x, and we will get that x cubed minus x equals to 6. Here we will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. Actually here minus 2x squared plus 2x squared equals to 0. So we actually can add 0 to any equation. Therefore we can add minus 2x squared plus 2x squared to equation number 1 because it equals to 0, and it is allowable to add 0 to any equation. So we'll do it now. We'll get that x cubed minus 2x squared plus 2x squared that equals to 0 minus 6 equals to 0. Minus 6 minus x also, so it is actually, I will write it again. X cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Okay, here we will substitute minus x. Actually, minus x equals to minus 4x plus 3x, so we can substitute minus x by minus 4x plus 3x because it equals to minus x. So we will do it now. We will substitute minus x by minus 4x plus 3x in equation number 1, and we will get that x cubed minus 2x squared plus 2x squared and instead of minus x we will write down minus 4x plus 3x minus 6 equals to 0. Okay, so we got this equation number 1. Here we will divide equation number 1 to 3 parts, and we will take a common factor from each part. So we will divide the equation number 1 to 3 parts. This will be the first part. That will be the second part. And that will be the third part. So we will take a common factor from each of the 3 parts. So the first part is actually x cubed minus 2x squared. Here we will take a common factor of x squared out of those two expressions, and what is left from x cubed, if we took a common factor of x squared, what is left, it is actually x, and what is left from minus 2x squared, if we took a common factor of x squared, what is left, it is actually minus 2. So in total, we found out that x cubed minus 2x squared equals to x squared times x minus 2. We will repeat on the same process for the second expression. So we will take a common factor from the second expression, that is actually 2x squared minus 4x, and the common factor that we will take from this expression is 2x. So what is left from 2x squared, if we took 2x as a common factor, what is left, it is actually x. And what is left from minus 4x, if we took 2x as a common factor, what is left, it is actually minus 2. So in total we got that 2x squared minus 4x equals to 2x times x minus 2. We will do the same process for the third expression. The third expression is 3x minus 6, and the common factor that we will take from this expression is 3. So what is left from 3x after we took 3 as a common factor, what is left, it is actually x. And what is left from minus 6 after we took 3 as a common factor, what is left, it is actually minus 2. So in total we got that 3x minus 6 equals to 3 times x minus 2. Okay? So now we can substitute x cubed minus 2x squared by x squared times x minus 2, and we will substitute also 2x squared minus 4x by 2x times x minus 2, and we will substitute 3x minus 6 by 3 times x minus 2 in equation number 1, and we know that the sum of those three expressions equals to 0 according to equation number 1. Okay, so we'll do it now. So we will take x squared times x minus 2, that equals to this expression, and then we will also take 2x times x minus 2, that equals to this expression, and we will take also 3 times x minus 2, that also equals to 3x minus 6, and we know that all equals to 0, the sum of those three expressions equals to 0. So in total we got this expression number 1 after we substituted the original three expressions by their identities. Okay? Here we can take a common factor of x minus 2 out of these three expressions, and we will get that according to equation number 1, x minus 2 is a common factor. So what is left from this expression after we took x minus 2 as a common factor? What is left is it is actually x squared, and what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually 2x, and what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually 3. Okay, in total, After we took x minus 2 as a common factor, we got this expression. So here we will have two possible solutions from this equation number 1. The first possible solution is x minus 2 equals to 0, and if x minus 2 equals to 0, anything that you multiply it by 0 equals to 0, so we will get that 0 equals to 0. The second possible solution is that x squared plus 2x plus 3 equals to 0, and if it is equal to 0, then all this side equals to 0 and 0 equals to 0. This will be the second solution. So I write the two solutions down. The first solution that is possible is that x minus 2 equals to 0. And the second possible solution to this equation number 1 is that the quadratic equation x squared plus 2x plus 3 equals to 0. We will focus on the second solution and we'll try to find out the value of x of this quadratic equation. The general formula for a quadratic equation is actually ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. When a, b, and c in this general quadratic equation are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to a special formula, according to the following formula. X actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. Okay, we will find out the value of x according to this special formula. And in our specific quadratic equation, x squared plus 2x plus 3, the coefficients of this specific quadratic equation are as follows. Here a equals to 1, b equals to 2, and c equals to 3. So what is left here is to put the data inside this equation formula for x in order to find out the value of x. So we'll do it now. We'll get that x equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, times c, c is 3, over 2 times a is 1, so 2 times 1 is 2. Okay, we got this expression. So x equals to minus 2 plus minus square root of 4 minus 4 times 1 times 3 is minus 12 over 2. So x equals to minus 2 plus minus 4 minus 12 is minus 8 over 2. So here minus 8 is a negative number, and a negative number doesn't have a root. Therefore we are stuck here. The negative number doesn't have a root, therefore the quadratic equation x squared plus 2x plus 3 doesn't have a solution. Therefore, this possibility is incorrect, we'll cancel this possibility, and the only possibility for the solution of equation number 1 is that x minus 2 equals to 0. Okay, so the only solution to this equation number 1 is that x minus 2 equals to 0. X minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. X equals to 2. And we have already found out, according to equation number 2, that the radius of the red semicircle equals to 3 over x. The radius of the semicircle equals to 3 over x according to equation number 2. We have already found out that x equals to 2, so we can put the value of x inside this equation number 2. And we will get that the radius of the red semicircle equals to 3 over x. X is 2, so it is 3 over 2 units, or it can also be presented as 1.5 units. Okay, so the answer to our question is that the radius of R of this semicircle equals to either 3 over 2 units, or it can be represented as 1.5 units. So the radius of this semicircle equals to either 3 over 2 units or to 1.5 units. That is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the radius of this red semicircle. And we have a triangle ABC that is a right triangle. Side AB equals to 3 units. Line segment DC equals to 1 unit. Angle ABC equals to 90 degrees. And we want to find out the radius of this red semicircle. So, first of all, I will present it to you. Rule number 1, or the two tangents theorem. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and we have external point P is the external point of this circle, and from the external point P we will draw two tangents to this red circle. The first tangent is PA, the second tangent is PB. Then whenever you draw two tangents from an external point of a circle to a circle, then the lengths of those two tangents will be equal to each other. That is to say, the length of the first tangent is PA, the length of the second tangent is PB. So PA is equal to PB. Okay? Whenever you have external point of a circle, from the external point of a circle you will draw two tangents to that circle, then the lengths of those two tangents will be equal to each other. That is to say, in this case, PA equals to PB. Okay, that is two tangents theorem, or rule number 1. We implemented two tangents theorem in our drawing. Point A is an external point of this right semicircle, and from point A we have two tangents to this semicircle. The first tangent is tangent AB. The length of tangent AB is 3 units. The second tangent to this right semicircle from the external point A is tangent AE. According to two tangents theorem, the length of those two tangents that are exited from the external point A to the circle are equal. That is to say, AB equals to AE. But we know that AB equals to 3 units. Therefore, from this equality, we will derive that AE equals to 3 units. Okay? We will derive from this equality that AE equals to 3 units. Okay? So we wrote here that line segment AE equals to 3 units. Okay? Then I presented to you a new rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point O, and we have the tangent AB. Tangent AB is tangent to this blue semicircle at point M. Point M is the point of tangency of tangent AB with this blue circle. And we also have the radius OM. This radius, it is drawn to the point of tangency. Therefore, the tangent AB will be perpendicular to this radius, according to rule number 2. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. I will repeat again. A tangent to a circle, that is to say, tangent AB, is perpendicular to the radius drawn to its point of tangency. So this radius is drawn to the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, this is the meaning of rule number 2, and we actually implemented rule number 2 in our drawing. In our drawing, we have tangent AC is tangent to this red semicircle at point E. Point E is the point of tangency. And we have this radius, OE, is drawn to the point of tangency. That is to say, is drawn to point A. To point E, that is the point of tangency. Therefore, the tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees, according to rule number 2. And because of the fact that angle OEC equals to 90 degrees, therefore the green triangle is a right triangle because it has one angle that equals to 90 degrees. So in the green triangle OEC, we can implement the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the green triangle is OC, so OC square equals to OE square plus EC square. What is the size of OC? From the drawing you can see that OC equals to R plus 1. If OC equals to R plus 1, then OC square will be equal to R plus 1 square. Okay, and OE equals to R, so OE square will be equal to R square, and EC equals to X, so EC square will be equal to X square. So in total we got that R plus 1 square equals to R square plus X square. We open the bracket of this side of equation number 1. R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. Here we subtracted R square from equation number 1, and we got that 1 plus 2R equals to X square according to equation number 1. Then we focus on the right triangle, triangle ABC, and on the green right triangle, triangle OEC. And we proved that those two triangles similar to each other. Okay, we focus on triangle ABC and on the green triangle, triangle OEC. Actually, we have those two angles that are equal to each other. They are both right angles. Okay, so angle ABC, triangle ABC equals to angle OEC, triangle OEC, and they are both equal to 90 degrees. They are right angles. And we also have this angle, angle C, is a common angle. It belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles. So angle C equals to angle C is a common angle. And we actually proved that those two angles are equal to each other according to third angle theorem. That is to say, angle BAC of triangle ABC equals to angle EOC of triangle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem is that third angle theorem, or rule number 3, says that if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of third angle theorem? The meaning of third angle theorem is that if you have two triangles that have two pairs of angles that congruent to each other, here this is the first pair of angles that congruent. They are both equal to alpha. And this is the second pair of angles that congruent. They are both equal to beta. So if this is the situation that you have already two pairs of angles that congruent to each other, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta. Okay? We proved actually that this third angle theorem is true by using the rule that says that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. In triangle ABC, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Then we subtracted equation number 1 from equation number 2, and we got that alpha minus alpha is 0, beta minus beta is 0, gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that gamma minus theta equals to 0. We added theta to equation number 3, and we got that angle gamma equals to angle theta. So we actually proved that if we have two pairs of angles that are equal to each other in two triangles, those two pairs of angles are equal to each other, are congruent, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta. Okay? We proved that angle gamma equals to angle theta. And we actually proved that the third angle theorem is true. Okay, then we continue to, we actually proved here in our original drawing that triangle ABC, all three angles of triangle ABC congruent to all three angles of the green triangle, triangle EOC. Therefore, we proved that triangle ABC is similar to triangle EOC according to angle similarity rule. Okay, so we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. And from that, we concluded that AB over AC in triangle ABC equals to OE over OC. AB equals to 3 units, AC, the hypotenuse equals to 3 over x. Okay, it equals to 3 over x units. OE equals to R, OE equals to R, and OC equals to R plus 1. Okay, OC equals to R plus 1. So in total, we got that 3 over 3 plus x equals to R over R plus 1. Here we multiply the equation number 2 and we got that 3 times R plus 1 equals to R times 3 plus x. We open the brackets in equation number 2 and we got that 3R plus 3 equals to 3R plus Rx. We subtracted 3R from equation number 2 and we found out that 3 equals to R times x. We divided equation number 2 by x. It is allowable to divide equation number 2 by x because x is one side of the green triangle and it must be a positive number. It can never be 0, therefore it is allowable to divide equation number 2 by x. And we found out, after we divided equation number 2 by x, we found out that the radius of the semicircle equals to 3 over x. But we have already found out, according to equation number 1, that 1 plus 2r equals to x squared. So we can substitute r in equation number 1 by 3 over x from equation number 2 because r equals to 3 over x. So we substituted r from equation number 1 by 3 over x and we got that 1 plus 2 times 3 over x equals to x squared. Here 2 times 3 is 6, so we wrote it down. And we got that 1 plus 6 over x equals to x squared. Here we multiplied the equation number 1 by x and we got that x times 1 is x, 6 over x times x is 6 and x squared times x is x cubed. We subtracted x from equation number 1 and we found out that x cubed minus x equals to 6. We subtracted 6 from equation number 1 and we found out that x cubed minus x minus 6 equals to 0. Here we added minus 2x squared plus 2x squared, that is actually 0, to equation number 1 and we got this expression that x cubed minus 2x squared plus 2x squared minus x minus 6 equals to 0. Here we substituted minus x by minus 4x plus 3x. Minus x equals to minus 4x plus 3x, so we can substitute minus x by minus 4x plus 3x. And after we substituted minus x by minus 4x plus 3x, we got that this equation number 1, we divided equation number 1 to 3 parts and we took a common factor from each part. From part number 1 we took a common factor of x squared and inside the brackets what we got is x minus 2. The common factor that we took from the second expression is 2x and what we got inside the bracket is x minus 2 and the common factor that we took from 3x minus 6, the third expression, is 3 and inside the brackets what we got is x minus 2. So we have 3 expressions and their identities, so we substituted those 3 expressions by their identities and we got this expression. From this equation number 1 we took a common factor of x minus 2 and after we took a common factor of x minus 2 from this equation number 1 we got to this equation x minus 2 times x squared plus 2x plus 3 equals to 0. Here we have two solutions that are possible. The first solution is that x minus 2 equals to 0, and the second solution is that the quadratic equation equals to 0. X squared plus 2x plus 3 equals to 0. We focus on the quadratic equation x squared plus 2x plus 3 equals to 0. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to a special formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And our specific quadratic equations, that the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation for x in order to find out the value of x. X equals to minus b, b is 2, so minus b is minus 2. Square root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4. Minus 4 times a, 4 times c. A is 1, c is 3, so minus 4 times ac is minus 4 times 1 times 3 over 2. Because 2a is 2 times 1 is 2. So we got that x equals to minus 2 plus minus square root of 4 minus 12, because 4 times 3 is 12. So, and the square root of 4 minus 12 is minus 8. Okay, so in total we got that x equals to minus 2 plus minus square root of minus 8 over 2. But because of the fact that a negative number doesn't have a root, with this quadratic equation doesn't have a solution because the negative number doesn't have a root. So this possibility is cancelled because this quadratic equation doesn't have a solution, and we're only left with the solution that x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2. And we have already found out that according to equation number 2, the radius of the semicircle equals to 3 over x. So we can put x equals to 2 inside this equation number 2, and we put 2 inside this equation number 2, and we got that the radius of the semicircle equals to either 3 over 2 units, or it equals to 1.5 units. I will repeat again. The radius of this semicircle equals to either 3 over 2 units, or it also can be represented as 1.5 units. Okay? We have two solutions possible. Either the radius equals to 3 over 2 units, either the radius of this semicircle equals to 3 over 2 units, or it equals to 1.5 units. Okay? Thank you very much.